Hello students, good afternoon. Today we shall discuss about the laws of motion. Perhaps everybody known about Newton who discovered the force of attraction by the earth or which is known as gravitational force of attraction. And he also discovered many formulas and many theories also. Out of them, he discovered three laws on motion. Before going to discuss about the laws of motion, we shall laws of motion. We shall discuss about what is rest, what is motion, and what is about force. These three things are necessary to know. So first we shall discuss what is rest. Rest means if a body does not change its position with respect to time, then we can say that the body is at rest. That means we are considering here a body which is placed over a table for a long time. Without applying any force, this body does not change its position from this place. That means if a body does not change its position with respect to time, then it is called is at rest. But this is our definition of rest. What is our motion? If we apply some force on the body and the body displaced through a certain distance from here to here after some time, then we will say that this body is in motion. That means if a body changes its position with respect to time, then we can say it is at motion. Now, important thing is what is force. Force means when we apply. So, it is an agent which when applied on a body, it tend or try to change. It accelerate or decelerate the motion of a body, then that is called a force. When we apply some force on a body, it may change or may not. It try to change. That means it may or may not possible to change the motion of the body, but it will try to change the motion of the body. So it is an agent. So we can say force, it is an agent which when applied on a body, it change or try to change the position of the body, that is called a force. Now we shall discuss about the laws of motion. Newton gave three laws on motion, that is first law, second law, third law, and first law gives the qualitative definition of force. So the first law says we are discussing about the laws of motion only. The Newton's first law says everybody continues in its state of rest or motion in a straight line unless it is compelled by some external force to change its state. Okay, everybody continues in its state of rest or motion in a straight line unless it is compelled by some external force. Okay, everybody continues in a state of rest or motion in a straight line unless it is compelled by some external force to change its state. That means it says that till we are not applying some force on a body, the body, if it is in rest, it keeps itself in rest position. But after applying some force, it changes its position. Till if a body continues in its state of rest, that means if it is at rest, it continue to be at rest. But if it is in motion, it continue to move in a straight line till we are not applying a force on that body. Okay, this is the definition given by Newton, that is, we are considering it as Newton's first law. So this Newton's first law gives idea about qualitative idea about force and also gives the idea about inertia. That means what is inertia? It gives an idea about inertia. This inertia, what is this inertia? Inertia is a property of body. That means its definition. Inertia is the property of body by virtue of which a body is unable to change its state without the help of an external force. Okay? Inertia is the property of body. Inertia is the property of body by virtue of which body is unable to change its state without the help of any external force. Okay? Inertia. What is inertia? Inertia is the property of body by virtue of which a body is unable to change its state without the help of an external force. That means till we are not applying some force on a body, it does not change its state. State means it may be at rest, it may be in motion, it may be something of different type. That means if we apply some force on a body, then only its position, its motion, its other situation can change. So, according to this inertia, inertia is divided into three types. I am just discussing here. That means inertia are of three types. What are they? The inertia of rest, inertia of motion, inertia of direction. Okay, there are three types of inertia: inertia of rest, inertia of motion, inertia of direction. So, inertia of rest. Now I am taking this inertia of rest. What is this inertia of rest? The same definition. We have to just make some changes. Inertia of rest. Inertia is the property of body by virtue of which a body is unable to change its state of rest. Okay, just you easily remember inertia of rest. Okay, or you can write here it is the property of body, or you can write it is the property of body by virtue of which a body is unable to change its state of rest without the help of any external force. That means when a body is at rest, it does not change its position without any external force. So till we are not applying any force on that body, it does not change its state. So I am discussing about some examples just to see. Perhaps a person sitting in a bus get a backward jerk. You have seen this type of things when a passenger or a person sitting in a bus gets a backward jerk if the bus starts suddenly. That means when the bus starts suddenly, the lower portion of the body, that means the foot, which is on the bus, changes its position with the bus. That means it moves with the bus, but the head is still at rest. So when the bus starts moving, the foot moves with the bus in forward direction, but the head is still at rest. So he moves just like he stays at that position, and like it feels that we fall on the back. So he get a backward jerk. In similar case, a bike, when a person sitting on a bike on its back seat, if the bike starts suddenly, the person sitting on back seat just falls his head to the backward direction. Okay, this is also an example of inertia of rest. Okay, now there are some other examples also. If we take a cardboard and placed it on a water glass and keep a stone above it, and we just apply some force on that cardboard moves from that upper portion, but the stone drops inside the glass. That is also due to inertia of rust. When we apply some force on that cardboard moves from that place, but due to inertia of rest, that stone is still at that position. Similarly, you have seen that when we are playing the carom board, when we strike the lower dot with the striker, the lower dot moves from that place to some other places, but other dots are still at that position. That is also an example of your inertia of rest. Now we shall discuss about what inertia of motion. Inertia of motion. Yes. What is this inertia of motion? It is the property we have just changed here rest to motion. It is easier to remember. What is inertia of motion? It is the property of body by virtue of which a body is unable to change its state of motion without the help of any external force. That means when a body is in motion, it does not change its motion without the help of any external force. As we have discussed in Newton's first law, till we are not giving a force to a body which is in motion, it does not change its direction or position. It just try to ride on a straight line. Okay, this is also another important thing, that is about inertia of motion. So we are thinking about some examples. Just a passenger sitting in a bus get a forward jerk. How it happens? Just remember, when the person get a forward jerk, that means when the bus stops suddenly, the lower part, that means the foot which is on the bus, stops suddenly. But as the bus moves, the person or the body still in motion with the bus. But when it suddenly stops, the head moves forward. So he get a forward jerk. That means a passenger sitting in a bus gets a forward jerk when the bus stops suddenly. This is also example of this inertia of motion. Similarly, a horse rider sitting on a horse get a forward jerk if the horse stops suddenly. But an interesting thing is there, when we are just telling, yes, when a person jumping from a running train falls his head towards the engine. This is an important discussion for exam point of view. A person jumping from a running train falls his head towards the engine. How it happens? Just you imagine. When a person jumping from a running train, that means he moves with the velocity that the train moving with. So the whole body is moving with the train. But when he jumps to the floor, that means the foot when touches the floor or the touches the ground, it comes to rest. But the whole body is still in motion. So he falls in forward direction. That means in forward direction, that means he moves with the velocity of train that moved with. So when he falls towards the, that means when he falls to forward direction, the engine also is there on the forward direction. So the question is just given in this way. That means when a person jumping from a running train falls his head towards the engine, because when he falls towards the engine. Okay, this is another discussion for inertia motion. Now we are going for a inertia direction. Inertia direction. When we are coming to this, the definition is the same. It is the property of body by virtue of which a body is unable to change its state of direction without the help of an external force. Okay, inertia of direction, it is the property of body by virtue of which a body is unable to change its state of direction or unable to change its direction without the help of an external force. Okay, that means just we are again taking one example for this bus also. A person sitting in a bus gets an outer jerk if the bus changes its direction suddenly. That means a passenger, just I am omitting this thing, a passenger when sitting in a bus, just a passenger, I am taking this one for a diagram. When the bus moving with some velocity in this direction, That means this person also moving with the bus with same velocity. But when suddenly it changes its direction towards this, the body is still in this direction. Okay, that means the body is moving still in this direction. So when it suddenly changes its direction, it feels that a outward jerk. If he moves in this direction, he is moving in this direction. That means if the bus turns to right, the person get a left side outward jerk. If the bus suddenly turns to left, the person gets a right side outward jerk. That means he is moving in same direction, but the bus changes its direction. So he get a outward jerk. This is the example of your inertia of direction. Okay, this is all about your Newton's first law or the idea about inertia. Now we shall discuss about the Newton's second law. Newton's second law. What Newton's second law says? Newton's give three laws. So Newton's second law, the rate of change of momentum of a body is directly proportional to the impressed force and takes place in the direction of the force. The rate of change of the rate of change of the rate of change of momentum of a body is directly proportional to the impressed force and takes place in the direction of the force. Okay, this is second law. The rate of change of momentum of a body is directly proportional to the impressed force and takes place in the direction of the force. That means it gives a quantitative, because rate of change of momentum, that means a quantity. So Newton's second law gives a quantitative definition of force. First law gives a qualitative definition of force, but the second law gives a quantitative definition of force. How it is? Just we are taking its mathematical derivation. Okay, just see. Rate of change of momentum, that means F proportional to rate of change of momentum. Rate of change of momentum. Okay, F proportional to rate of change of momentum. That means d by dt of p. P is the momentum. That means this is equal to d by dt of p, means mass into velocity. So we can write it as mass is constant taken outside, dv by dt. But we know dv by dt is equal to a, so it's proportional to m into a. If we are taking this proportionality out, we can write f is equal to ma, and one constant is the kma, where k is known as the proportionality constant. Or if k is equal to 1, then f is equal to ma, or force is equal to mass into acceleration. Okay, this force is equal to mass into acceleration. Just see, rate of change of momentum. That means rate of change means the momentum changes with time. So we have taken d by dt of p. As you know, p is equal to m into v, mass into velocity. So d by dt of mass into velocity. Mass is constant taken outside of the derivative. So m dv by dt. Where dv by dt is the acceleration. So we have taken right m into a. As it is a proportional, so we can take it out. When we are taking out proportionality, then we can put a constant here. So f is equal to kma. If k is equal to 1, then f is equal to ma. That means mass into acceleration. Okay, force is equal to mass into acceleration. Now erasing this one, we will go for the units of these forces. Okay, units. First we shall take CGS unit. CGS units. As you know, F is equal to MA. In CGS system, mass is equal to 1 gram, acceleration is equal to 1 centimeter by second square. That means 1 gram into 1 centimeter by second square is equal to 1 dyne. Okay, so F is equal to what? 1 dyne. Now, in MKS or SI system, MKS unit, F is equal to MA, that is equal to 1 kilogram into acceleration 1 meter by second square. So it is equal to 1 Newton. Okay. So the CGS, in CGS unit, the unit of this force is equal to 1 dyne. In MKS unit, the unit of this force is equal to 1 Newton. So there is a question arises in our mind, is there any relation between this Newton and dyne? Now we shall discuss about this. What is the relation between this Newton and dyne? I am taking this Newton. Okay. So 1 Newton is equal to how much? 1 kilogram into 1 meter by second square. Okay. 1 kilogram is equal to how much gram? 1000 gram. 1 meter is equal to 100 centimeter by second square. So we get 10 to the power 0, 3, 4, 5 zeros are there with gram into centimeter by second square. It's equal to dyne, so it gives 10 to the 5 dyne. Okay, so 1 Newton is equal to 10 to the 5 dyne. Remember this, 1 Newton is 10 to the 5 dyne, or 1 dyne is equal to 10 to the power minus 5 Newton. But this said 1 dyne is equal to 10 to the power minus 5 Newton. Okay, so this is the simplest unit, and in gravitational unit we can also change this one in gravitational unit. In gravitational unit. Okay, this F is equal to M, where M is equal to 1 gram CGS system. In CGS system, 1 gram into acceleration, that is equal to 980 centimeter per second square. Okay, which is equal to 980 dyne. 980 dyne. So this is equal to 980 dyne, or it can be written as 1 gram weight. Okay, in CGS system, in gravitational unit. Similarly, in gravitational MKS system, we can write F is equal to MA, which is equal to 1 kg into, this is equal to acceleration is 9.8 meter by second square, which can be written as 9.8 Newton, or it can be written as 1 kg weight. Okay, in CGS system, for gravitational unit, in CGS system, force is equal to 1 gram weight, which is equal to 980 dyne, or in MKS system, 1 kg weight, which is equal to 9.8 Newton. Okay, so this is all about our second law of motion. Now Newton's third law. Newton's third law. Newton's third law on motion. What it says? To every action there is an equal and opposite reaction. Everybody knows it. To every action, there is an equal and opposite reaction. Okay, to every action there is an equal and opposite reaction. That means if we are taking an action, then must be a reaction is there. It says the third law. Just example, if we throw a ball to the wall with some force, the ball rebounds back to us with the same force. If we increase every time with some force, that means the increase the force, we will realize that ball also coming with some excess velocity or excess force. Similarly, if we are when we are walking on the road, we push the earth by our foot in backward direction. Okay, as a result of which the earth pushes us in forward direction. You have realized while walking we are pushing the earth in backward direction, but as the earth is heavier mass, it does not change its position, but it gives the same amount of force to our foot, so foot moves forward direction. As a while we can able to walk in a with some speed. Similarly, while if we are moving in a boat and jumping from boat to the floor or the ground, at its when we are moving in a river, we see that when we jump from the boat to the shore, the boat moves backward. Similarly, it gives an opposite force by which we can able to come to the ground and reach the ground with the same force. These are the some examples which are given by Newton's law or concluded from Newton's law. So you can realize this Newton's third law in various ways, and you can discuss with this. So this is all about your Newton's first law, second law, third law. For getting this type of few important topics, you can subscribe the channel Jagdev Sir Physics, where you can see my different topics on different books from different books, so you can easily assess your course. And basically my topic are based on plus 2 science students, for engineering students, for 11th student of CHSE and CBSE mediums, and for 12th class CBSE and CHSE mediums, and also for engineering students. So you can, if you want to see my topics or my lectures, you can subscribe Jagdev Sir Physics and Mathematics. Okay, thank you.